This is activity 4, lab number 6. In this lab we have been doing the following problem several different ways. Activity 4 is when I try to do this shell problem, folded sheet metal clamped at the edges and pressurized on the top, thickness is given. I'm going to use it with a weird way, and that is create a box, create a box, okay, and extract the surfaces, top and the side face, and that's going to be a quarter of this model basically. Now, when you extract that, these surfaces don't talk to each other, so we're going to join it. But when we join it and you put a thickness on it later on, it's going to put both on the top and the side face, because this problem is when the top face has a different thickness than the side face. The activities 1 and 2 were assumed that the thickness was the same everywhere. Here I'm going to assume the top face thickness is 0.1 and the side face is 0.05. Okay, so when I join it and put 0.1 on the top, it's put it on both sides, which I then have to go and do a local 1D property and change the one on the side. Okay, so let's go ahead and do that. This is a different way of doing activity 3, except that we're going to create a three-dimensional box and then extract the faces. So let's go ahead and do that here. Because we're going to be making a box, we should be in part design. Right now, uh, I'm in generative shape design. So let's switch to part design, mechanical design, part design. Notice that the gear shows up. So on that face, I will sketch 1/4 basically of that block that you see there, or that you see 1/4 of that uh, big dimension. So let's see now, dimensions here. This is going to be 1, and this is going to be 0.5. Exit, and then palette. Okay, palette by 2 inches. Okay, if you prefer, I can turn this thing around so that you see basically this situation. Okay, good. Now, why don't we apply material property to this? So we go here, metal, let's see, where is that? Yellow brass on that part. Okay. Now I want to extract this top face and the bottom face. It cannot be done in the part design, so we're going to switch to generative shape design or wireframe and surface design workbench, whichever you prefer. This is the more mature version of the other one. And look in the operations toolbar where you see the joint, the third icon from the left. This is the extract. Now, if I want to do this thing one by one, I can do that. But if I want to do it at the same time, because I'm too lazy, so this one, control that one, and then say extract right there, and I do it at the same time. Otherwise, you have to do it twice. Now, the fact that it's doing it at the same time doesn't mean that that duplicate nodes issue is solved here. So now we're going to join these two. So when you join it, later on, when you create a mesh on this thing, it's going to be created on both sides, okay? And there's no duplicate nodes there because we joined it. That's right. Now I can hide this. But I cannot delete it because these surfaces were created out of that object. I'll just leave it in plain view here so that you can see it better later. So we're going to switch to generative structure analysis. Catia immediately sees a three-dimensional object and it meshes it. Let me change the rendering. It immediately meshes this box. Now I don't want that box, so I'm going to delete this, delete that mesh for the box, and then delete the 3 property. Do not forget to delete this, otherwise it becomes an orphan property. It says, I don't know what to do with it, etc. Okay, so now let's go ahead and mesh it. See that? Mesh with shell element. Now I don't want this. I don't want this surface, this box. I just want the surfaces to be meshed. So click on it, select it, and it's going to be done. And you can see that actually, if I say show me the mesh, it will show it to you. And if you zoom in, you see that the nodes on this side and that side are identical along that edge. Very good. Deactivate this. Now, I'm going to put a 2D property, but because these are joined, when I put it, it's going to put on the side and right there. Let me hide this. It will put it on the side and this because you joined it on the horizontal uh, surface and the side surface. Okay, but I don't want that, so I say okay. But then you go here, right-click local 2D property. You click on it and you select the thing that you want to change, and 0.05 is what I wanted there. The reason it knew it was 0.05 because I already did a video earlier about activity 3 and it used this. So, good. This thing you can leave it here or hide it. It really doesn't have an effect as far as the FEA is concerned. The rest of the problem is the same as before. So this bottom is edge. If we pretend that these are in the plane of symmetry, because it could be that the other one is in the plane of symmetry, it's up to you, it really doesn't matter. So let me do the following, user defined, let me uncheck all of these. You gotta read these, look at this thing very carefully. This edge and that edge, they lie in the XY plane of symmetry. See that? XY plane of symmetry, so no displacement in direction Z, rotations is exactly the opposite. And let's do this edge. So this edge lies in the YZ plane of symmetry, no displacement in X, and rotations exactly opposite. I just want to check this previous one that we did, make sure I didn't make a mistake. So that's these two, no displacement in Z, rotation opposite. Very good, good. That's correct. So pressure on the top. Now notice that because of the way I did it, this direction is not correct, so I have to take this minus and flip it. That's good. And we're going to run it. And you can see, yeah, that looks good. Uh, yep, change the rendering here, material shading. There we go. The rest of the problem is the same. Now, while we're here in this activity, what I'm going to do is I'm going to close this. I don't want that. Let's go back here and notice that I did join. Remember I joined? So I right click and delete this join. Okay, and pretend that I want to do the problem without joining these things. Remember, this is in the background. It is in the background. No problem. It's in the background. I don't need it, so I'm just going to hide it. If we repeat this thing, we go to analysis and simulation, generative structure analysis. I did not do a join. I deleted my join. Turn this thing around if you feel more comfortable. Change the rendering here. Change the rendering. Now this is a three-dimensional object that was three-dimensional mesh that was created because the block sits in hiding, it's in the background. So I have to delete two things. I have to delete this just like I did a minute ago, delete this and delete that. Now when I do the meshing, because I did not join these two, when I select this, it just does the top. And I should convince you by saying right-click mesh visualization. So it doesn't do the side because we did not join it. And do it again for the side, like that. And now when I say, show me the mesh, we'll activate the mesh. And if you zoom in closely, you see that on this side, for example, the node number of 6 80 and 5, and on this side is 290, 341, etc. So there are duplicate nodes, and this has to be handled in activity that I'm going to call 4.5. Okay, activity 4.5, and this is where I solve this problem for you. Okay, show you how to tie these two. If you don't join, you have a problem. Now, also keep in mind that, let me deactivate this. I can do the thickness on the top, 0.1, no problem. And the thickness on the side, I have to do them separately. And this one is 0.05. Okay? Still, I have a problem that let me show you what happens when I try to load these things. Clamp this, clamp that. And let me see now. This one was that, I believe. This edge lies in the YZ. Uh, this edge lies in the this edge lies in the YZ plane. No displacement in X. Rotation is opposite. Yeah. And these two edges, this edge and that edge, lie in the XY plane. No displacement in Z. Rotation is opposite. And put a pressure on the top. And watch that when I run it, it's gonna bomb out, because basically these do not talk to each other, and this just moves as a rigid body. So see that? It'll bomb out right here. If you want to see what happened, you can always interrogate it and ask it to animate. You can see that these two guys are not connected to each other. That's why it didn't run. All right, that takes care of this. In activity 4.5, I'll show you how to do this problem using the analysis connection. Basically, tie the nodes on this side to the nodes on that side and declare it, for example, as rigid or smooth, whatever you want, and you'll solve the problem. Okay, where is this? That'll be activity 4.5.